Okay, so if we have a system of equations that's in 3 variables, this is where things get a little bit more complicated than solving with 2 variables. And the way we're going to talk about how to do this today is basically using elimination. Okay, the idea is that I'm going to pair up my equations and try to eliminate the same variable in both of those pairs of equations. So in general, there's not a right or wrong variable to pick to eliminate. It's just that there could be one that's easier than the rest. Like in this particular instance, my y will be the easiest to eliminate because I'm already set up to eliminate. They already have the same number in front, but one of them is positive, the other two are negative. As long as one of them has a different sign, whichever way it goes, then that's really helpful as far as being able to eliminate. Since this is a positive 4y, I can pair it with this negative 4y, and that will cancel. So I'm going to pair up my first two equations together, the first and the second equation. That's where I'm going to start. Okay, and then I compare my top one, which has positive 4y, with the bottom one, which has negative 4y. So that's 4x plus 4y plus z equals 24, and 5x minus 4y minus 5z equals 12. Okay, now I'm going to actually add these together, because that's what we do when we eliminate, we add the equations together. Well, what my goal was to eliminate my y's. 4y minus 4y, that's 0. 4x plus 2x gives me 6x. Z plus z gives me 2z. And then 24 plus 0 gives me 24. So now I have one equation that does not have y, it just has x and z. Now I'm going to solve my other equation. Okay, I am going to cancel out my y's. 4x plus 5x is 9x. Z minus 5z is negative 4z. And 12 plus 24 is 36. Okay, so I have another equation where I've eliminated y and just have x and z. Again, I picked y because the numbers already matched up. So I knew by pairing the first and the second, the first and the third, that I'd have a really easy elimination where I wouldn't have to multiply either of my equations by anything. Now I'm going to move this equation over here so that I can get a better look at these two equations together. Okay, I am now going to try to eliminate either x or z. It doesn't matter necessarily which one I pick, but there might be one that's easier. For example, there's nothing I can multiply 6 by to get 9, but if I multiply by 2 on this 2z, I can get 4. And if I multiply by a positive 2, then my signs will be different of 4z minus 4z, which will end up giving me something that eliminates. So that gives me 12x plus 4z equals 48, because I have to distribute that 2 to everything. I can't just times the z by 2 and call that good. I have to go ahead and distribute it to everything inside of my equation. So now I'm done with that, at least for now. I can come back and use it later if I want to. And I'm trying to add these two equations together. Well, the z's cancel out. 9x plus 12x is 21x. 36 plus 48 is 84. So I can divide by 21 on each side. Then I get x equals 4. Okay, that's my first variable. I still need 2 more, y and z. So what I'm going to do is I'm going to go back to the last equation I had that had 2 variables. Okay, So I need to plug in one of my equations that's back up here. Any of these three that I have, okay, which this one over here is one of these three, any of those three will give me what x is. Okay, so I'm just going to pick the 9x minus 4z equals 36. Again, you can pick any one of them you want, and you should still get the same answer as long as we all do it right. Okay, but I'm just taking what x is and plugging it in so that I can find z. Well, I have to do 9 times 4 is 36 minus 4z equals 36. When I subtract 36 over, what I end up with is negative 4z on the left, and 36 minus 36 is 0. I divide by negative 4 on each side, and I get z equals 0, because 0 divided by negative 4 is 0. So then I have two of my variables, x equals 4 and z equals 0. I need to go back to one of my original three equations and plug those in so that I can find y. It does not matter which one you pick. I'm going to pick the first one just for fun. Sometimes there will be like one that stands out as probably like the easiest one to plug into, but that usually happens if I have a one that doesn't have any like numbers in front of the variables. That would make it a little quicker, but none of these really have that as a case. So 4 times 4 gives me 16 plus 4y plus 0 really doesn't make a difference because 16 plus 0 is still 16 if I add like terms. So I subtract the 16 over, and I get 4y equals 8. So then I would divide by 4 on each side, and I get y equals 2. So now I know that x equals 4, y equals 2, and z equals 0. So that's all of the letters that I had there to solve. Okay, so that's one example of how to do that. I'm going to have some separate videos with some more examples.